Today, we're going to dive into a feeling we have all experienced, but maybe never really put a name to. We're calling it the universal stubbornness. And trust me, it governs pretty much everything, from your morning coffee all the way to the planets themselves.
You know exactly what I'm talking about, right? The traffic light turns green, the driver floors it, and bam, you feel like you're being pinned to your seat. Or maybe they have to slam on the brakes, and suddenly you're lurching forward, fighting your own seatbelt. It almost feels like some invisible force is just messing with you, pushing and pulling you around inside the car. But what's actually going on? Well, it's not a mystery force at all. Turns out, everything in the universe, and that includes you, has this built-in, kind of stubborn streak. So, this stubbornness of stuff isn't just a quirky way to describe a feeling. Nope. It is a fundamental rule of the entire universe. So let's break down what it really is. Now, the official scientific name for this stubbornness is inertia. At its core, it's the resistance that any physical object puts up against a change in its motion. You could almost say it's like everything in the universe just wants to be left alone to keep doing what it's already doing. And honestly, it really is that simple. Objects just want to keep doing whatever they're already doing. If something is just sitting there, it wants to keep just sitting there. And if it's moving, it wants to keep moving in a perfectly straight line at the exact same speed. That's inertia in a nutshell. Now, this incredibly powerful idea didn't really become a cornerstone of science until one person, Sir Isaac Newton, finally wrote it all down as a fundamental law of the universe.
And here it is, Newton's first law of motion. It sounds pretty simple, right? But that little phrase at the end, that unless acted upon by an unbalanced force, that's the key. That changes everything. Let's look at the two big parts of this law.
So the law really gives us two main scenarios. Part one, an object at rest. That just means something that's not moving isn't going to magically start moving all on its own. And then there's part two, an object in motion. This means that something that is moving will just keep on going, at the same speed, in the same direction, pretty much forever. Unless, of course, something gets in its way.
The first part of that law is super easy to see everywhere. I mean, look at your coffee mug or your phone sitting on the table. They're not just going to start sliding around for no reason. They're going to stay put, all thanks to their own inertia. But that second part, the in motion part, that can feel a little weird. I mean, why don't we see things just moving forever here on Earth? If you slide a book across the floor, it eventually stops, right? Well, that's because our world is basically swimming in all these invisible forces that are constantly messing with an object's perfect, stubborn motion. And that brings us to the final and maybe the most important piece of Newton's law, the push and the pull. So what does it take to overcome an object's stubbornness, its inertia? Well, you need an unbalanced force. This is Newton's big unless. It's any kind of push or pull from the outside that isn't canceled out by another force. It is the only thing in the universe that can actually cause a change in motion. Okay, think about an air hockey table for a second. That puck just seems to float, and with the tiniest flick, it glides almost perfectly across the surface. That's because there's almost no friction. But out here in the real world, on a regular surface, a force called friction is always acting against that motion. Friction is that unbalanced force that grabs the puck, overcomes its inertia, and grinds it to a halt. And here on Earth, we are just surrounded by these kinds of forces. We've got friction from the ground, we've got air resistance pushing against us when we move, and of course the constant pull of gravity. All of these things working together are the reason things eventually stop, and why that in motion part of the law isn't always so obvious in our daily lives. All right, now that we have all the pieces of the puzzle, inertia and unbalanced forces, let's put it all together and see how this one principle shows up absolutely everywhere. So let's go all the way back to that car ride. When the car shoots forward, your body, because of its inertia, wants to stay exactly where it was, at rest. So you're not actually being pushed back into your seat. What's really happening is the seat is applying an unbalanced force to you, pushing your body forward, making you accelerate with the car. That pressure you feel, that's just your own body's inertia resisting the change. So what about when the driver hits the brakes? Well, the car stops because of the massive force from the brake pads. But your body? Your body's inertia wants to keep right on moving forward at, say, 40 miles an hour. That is why you lurch forward. And your seatbelt? That's what provides the unbalanced force needed to stop you.
And once you see it everywhere. Headrests in a car? They're there to stop your head from stubbornly staying put if you get rear-ended. You know that old magic trick where you yank a tablecloth out from under a pile of dishes? That only works because the dishes have enough inertia, enough stubbornness to resist that quick pull. And way out in space, a satellite is always trying to fly off in a straight line because of its inertia, while Earth's gravity is the constant unbalanced force that keeps pulling it back into a perfect orbit. So think about it. From your coffee cup sitting stubbornly on your desk to the incredible motion of entire galaxies, this one simple law of stubbornness is always at work. It's a fundamental rule of how the universe operates. And it really makes you wonder, doesn't it? If the entire physical world resists change this much, what does this universal stubbornness tell us about the nature of change itself?